Given a binomial distribution, we can find the mean, variance, and standard deviation. And there's these formulas: mu equals n times p, sigma squared equals np 1 minus p, and sigma equals the square root of that variance. Remember that n is the number of people that you select. P is the probability of a success, whatever you define as a success. And Q is the same as 1 minus P, which will be the probability of failure. So in a recent poll of adults, 65% of those surveyed supported keeping the Affordable Care Act. So find the mean, variance, and standard deviation for the number of people who support keeping the Affordable Care Act when 40 adults are randomly chosen. So here we're choosing 40 adults, so N is 40. P is the probability of success, which we're defining as keeping the Affordable Care Act. So that'll be 65% or 0.65. Okay, so just plug your values in the formulas. For the mean, mu equals n times p, so that's 40 times 0.65, which is 26. For the variance, it's n times p times 1 minus p, so 0.35 comes from 1 minus 0.65. So that'll give you 9.1 for sigma squared, which is the variance. And then the standard deviation is the square root of that variance. So the standard deviation, approximately 3. Okay, another example, I'll just give you a minute if you want to try it. 30% of visitors to a certain website make a purchase. If the website gets 20 visitors, find the mean and standard deviation for the number that want to make a purchase. Okay, so if you use the formulas, and then in part B, if 5,000 people visit the website, find the mean and standard deviation for the number that make a purchase. Okay, so using the formulas, n times p, so there's 5,000 people, probability of a success is 0.3. So you would expect 1,500 to make a purchase if 5,000 people visited the website. And another way to look at expected value, or mu, for a binomial distribution is just think about if you toss a coin. The two possibilities are heads or tails. So if you toss a coin, say 20 times, how many heads would you expect? You would expect half of them to be heads. So if you did n times p, that'd be 20 times a half, which is 10. Okay, so that's just a basic way of looking at why n times p is the mean for the binomial. Okay, standard deviation isn't as easy to understand. Okay, but that's how you can understand the mean. And just one thing I want to point out here is with the binomial, the other questions you can be asked is, suppose if the website had 5,000 visitors, what's the probability that less than 1,500 would make a purchase? So you can, even with these large numbers, you can go to your binomial, so second vars for the distribution, and say less than 1,500 would be a binom CDF, and you want to find from 0 through 1499, because less than 1,500 would be up to 1499. So there's 5,000 people you're choosing, and the probability of success is 0.3, and you want to choose up to 1499 of them. So less than 1,500 would make a purchase. That probability is almost 50%. Okay, so about 0.4947. So about 49.5%. Okay, so even with the big numbers, you can still use the binomial CDF on your calculator.